So in the previous video I was showing you where a function was increasing, decreasing, and constant, and I mentioned the words maximum and minimum, and I hope it made sense what I was talking about there. Here's the formal definition. Maximum and minimum is just the high and the low points on a graph. We do have to be a little bit careful with our formal terminology here. We have a difference between, and each of these we kind of have synonyms for them. We can have the absolute or the global maximum and minimum, where the absolute or global maximum would be the highest point on the entire graph, and a lot, like the one in the picture here, don't have one because they go off to infinity. And same thing with a minimum. That would be, if it was a global or an absolute minimum, it would be the smallest point on the entire graph. And again, this graph that you see in this picture doesn't have one because it goes off to negative infinity. This graph does have what we call local or relative maximum and minimum values. Okay? And those are Latin endings with the the plural ends in an A, maxima, minima, and the word extremum or extrema means both, the extreme values of a graph, we call them sometimes. But a local or a relative maximum is the highest point in a region, okay, in a neighborhood around a certain value. So f of a is a relative maximum if f of a is the high point for all the x's around a on both sides. Okay? In the formal definition, it's got to be on both sides. An endpoint can't be a local or a relative maximum or a minimum. And the minimum is the opposite. It's the low point. F of b would be a relative minimum if f of b is less than all the y values f of x for x is near b. So these are just your high and your low points on the graphs, tops and bottoms of humps, or you may have sharp corners like on absolute value, but max and mins are the high and the low points. And we're talking about the relative or the local max and mins. And that's usually what we're talking about in this class, so often I'm just going to say maximum and minimum. So here's an example. I'll show you how to find them with the calculator. So using the calculate menu on your calculator, find all local maxima and minima for this fifth degree polynomial. F of x equals x to the fifth minus 4x to the third minus x squared plus 2x. So I've got the screenshots if you download and flip through the PowerPoint, but I'm going to actually show you here with the emulator. Okay, so I've got my TI Smart View here from Texas Instruments, which shows you the same thing as your calculator, whichever version you have. This one's the TI-84 Plus edition I've got loaded up here right now. So let's see, let's do y equals and clear out this trig function I had graphed there. And I'll do x to the power 5 minus, oops, got to make sure you drop out of the power if you're in the math print here, minus 4x to the third minus, did it again. You always got to do the arrow ahead to drop down out of the power, minus, let's see, x squared plus 2x. Okay, and then I'm going to hit zoom 6, go to the standard window, looks pretty good, but this is also a nice place to show you the zoom box command. This is a really good place to use the zoom box command. We're interested in, this graph has 2 max and 2 mins, okay? So we can see them here, and I could use this screen, but I might want to zoom in, which I could just do this. I could just do zoom in, choose number 2, hit enter, it'll zoom in around the cursor, and that's not too bad, although now it's zoomed in and we can't see one of the mins. So I'm going to zoom back out. I'm just going to do zoom 6 again. Zoom box is really nice if you want to put a box around a particular part of the graph. So I'm going to do zoom number 1. And what you have to do is move the cursor to one corner. Use the arrows to go to one corner of a box you want to make and hit enter, and that's going to set that corner. And then when you move it, it's going to start dragging a box. And it's a little slower than if you were on a computer and could just do a drag of your mouse, but it'll get there if you just keep hitting the arrows and put the box around it and then hit enter, and it'll zoom in around what you just put the box on. Okay. So this is nice. I can really clearly see the max and mins now. So what I do is I hit second and trace to go into the calculation menu, second and trace, and numbers 3 and 4 will show me maximum and minimum. So it doesn't matter which one we do first. Let's go from left to right. I'm going to do a maximum, so I'm going to pick number 4. And what I have to do is trap it. See, there's more than one. What it'll do, if I give it an interval to look at, it'll just find the largest value in that interval. So I have to make sure that the max I want is in that interval. So I move to the left easiest way, if you have it on the screen, you can type in x values, but the easiest way is to actually move on the graph. So I'm going to go to the left. In terms of a polynomial like this, where it's made out of humps, you can just think, I'm going to click on the left side of the hump. Okay, so I'm going to go until I go to the left of the max I'm looking for. Click enter, and it's going to give me a little arrow. On the newer calculators, it also gives you a little dotted vertical line all the way down, but it's going to look to the left of that, and then it asks me for a right bound, so I go to the right side of the hump somewhere here and click enter. So in between where I clicked, it's going to sample the y values and find the largest one. So click enter again when it says guess, and there you go. We've got a maximum at approximately x is negative 1.38, if we rounded 0.84 for the y value. And I just have to do that 4 times. I do second, trace, and choose maximum again. Let's go ahead and do the 2 maximums. This time I'm going to type values in. I'm going to type in 0 for the left bound. I could move on the graph, but if I type the x, that'd be a quick way to set it at 0. I think on the scale that's a 1. I'm going to try using 1 as my right bound. Yeah, there we go. So that max is somewhere between 0 and 1, and then hit enter the 3rd time for the guess. And there we go. Our max is at about 0.34, 0.41. Okay. These are all on the screen as well. In a minute I'll show you a recap of them. And then for the mins, you do the same thing, but pick min. Second trace, pick number 3, and you got to do the left and right bound. The quickest way, if you can see a good scale there, is just to type them in. I can do a left bound of about -1, and then a right bound of 0. And then hit enter for the guess. So I've got a min at about -0.54 with a y value of about -0.79. I usually round to a couple of decimal places. And then one more, the min down here. So second trace, number 3. This time I'll click on the graph. I'll go to the left side of that hump that I'm looking for here. Enter. Go to the right side. Press enter. And then finally enter again, and we have a min at about 1.58 with a y value that is the minimum there of -5.27. Okay, so that's how you find max and mins with your calculator. And if you download the PowerPoint, you can go through the screenshots there. We type in our function, take a look at the picture there in the standard window. I just did it in the standard window here, and you can't see all the keystrokes, but there's the maximum, the minimum, the other maximum, and the minimum.